Or for my computer or need your laptop. Where is it? Actually, never mind. It's okay. I found it.
Okay. So I do want to go over yesterday's homework. So I want you guys to take out this question here. And so we'll just kind of go over it quickly, I guess. So A asked for f of 4. So we said f of 4 would be equal to f of 0 plus the integral from 0 to 4 of f prime of x dx. And for the integral from 0 to 4, so this becomes 6 plus, yesterday we had talked about this being essentially the area of the square minus the area of the semicircle. So that was 4 minus 1/4 pi times 2 squared, which is 4 minus pi, because 2 and the 1/4 will cancel out. So 6 plus 4 minus pi. Then next we're going to do the area of this triangle. So that's 1/2 times 2 times -2. So we're going to get 6 plus 4 minus pi minus 2. And then next we have the area from here to, oh no, we just wanted from 0 to 4, right? So now we're at 4, so we're good. So this now becomes 6 plus 4 is 10. 10 minus 2 is 8. So it's 8 minus pi. All right, B asked, where does this graph have a point of inflection? And it's the graph of f prime. So what happens for points of inflection are they can only occur at kind of at those extrema. So points of inflection can only occur technically at that's a local min, a local max, kind of a kink, a local min. Technically, they possibly could occur at a jump because that's a discontinuity. So those are the only options for local extrema. And the reason for that is, remember that I think we had a chart at one point. We kind of made a chart of like what's happening to F, F prime, F double prime, right? Like when F of X was positive, we just don't know anything about F prime. When F prime is negative, we don't know anything, right? When F prime was 0, we don't know anything, blah, 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 blah. Well, for critical point, or for inflection points, we knew that basically inflection points, F had an inflection point when F double prime was 0 and, was changing from positive to negative or vice versa. So this was when F prime basically has a critical point, meaning it's at a max or at a min for the F prime graph. And it's where it changes, right? So it's where it changes from between increasing and decreasing. So basically on our F prime graph, anytime that we have kind of a max or a min, that's where it's changing between increasing and decreasing on the F prime graph. Now, technically, I was saying a jump technically could be it. And the way a jump could work is, see how we're increasing here? If we had a jump and it started decreasing, well then, technically, yes, at this jump, whatever X value this was, it was changing between increasing and decreasing. So basically, anytime you have a max, a min, or some kind of a kink, jump, discontinuity type deal, we can check it. So at -3, it's a possibility, but at -3, we don't change, right? We go from constant to decreasing, so we didn't change between increasing and decreasing. Now at -1, we do go from decreasing to increasing. So -1 is an inflection point. So X equals -1 because F prime changes from decreasing to increasing at X equals -1. Then X equals 0 does go from increasing now to decreasing. So X equals 0 because F prime changes from increasing to decreasing at X equals 0. All right, X equals 2, it was decreasing and then it continued to be decreasing. So we see how 2 is not, it's not a relative max or a relative min, so it can't be an inflection. And finally, X equals 4, it was decreasing, now it's increasing. That's the same as -1, so I'm going to just kind of do -1 and 4 together. Okay. Or we can say at, X equals -1 and 4 if we want to. So that's really all we need. You could have said something about F double prime, but I like to use F prime because that's the graph we have. We don't have a graph of F double prime. All right, C says find the maximum value between -1 and 4. So the maximum value for F. So first thing is we're going to set F prime of X equal to 0 to get our our critical points. We do that anytime we're trying to find a max. That's step 1. That's like a point just for writing that. Okay, now the zeros in this case, it's between -1 and 4. So -1 isn't a 0 because we want in between. So 2 is a 0. And then that's really it. So our table would be x and f of x. And we would have -1. We said +2. And 4, right? We have our endpoints and our critical points. Now, we can write like x equals 2 cannot be a max because f prime of x decreases before and after. Right? Oh wait, never mind. This is my fault. That's totally wrong. I was going with f prime, right? F prime is decreasing before and after, but f, this is totally my bad. What was f doing here? F was positive here. So when I was writing increasing and decreasing, what I was writing is that this is where students get confused, and I totally understand. Okay, I was writing f prime is decreasing, f prime is increasing, f prime is decreasing, f prime is decreasing, and f prime is increasing. I want to emphasize the prime part there. Because what is f doing? Well, here f is above the axis. So f is increasing because it's above the axis. F is increasing because it's above the axis. F is increasing because it's above the axis. Even though we're going down, F is increasing because we're above the axis. What does the F prime decreasing mean about F? So what the F prime tells us is, like what I have in green, that if the F prime was increasing, that means about F that, oops, F was concave up. Here, F prime decreasing means F was concave down. That's why that's why we have an inflection point at 2, because it changed from F concave up to F concave down. Why? Because F prime changed from increasing to decreasing. But F, that original graph, stayed increasing. I know that's a weird concept to think about, but it's kind of, yeah, concave up and concave down depend on what Nathan was saying, but they depend on F prime increasing goes with F concave up. Now, F prime positive goes with F increasing. So when we're concerned about max and mins, that's what we're concerned about. So on the graph, we're just concerned for this question about is it positive or negative. So now until 4, right, because we were going like between -1 and 4. So it was increasing because it was positive, increasing because it was positive. And now after 2, it starts decreasing because it's negative. So F would be, F would be decreasing because that value is negative. So actually what we can kind of say is that if we made a number line between -1 and 4, and then we have our only critical points at 2 for F prime, right? It's positive between -1 and 2, and negative until 4, which means it increases and then decreases. So actually, based on this number line, I was saying it backwards. Based on this number line, 2 has to be our, that has to be our critical point, or our maximum. So if we're kind of smart about this, we could actually cross out, so I said cannot be our maximum. It's actually that x equals 2 must be the max, because f prime of x basically only increases until x equals 2 and decreases after x equals 2 over (-1 to 4). So if we had written that, you could get away with not solving for (-1 and 4). Like you could just do x equals 2 and be fine. But you would have had to write that explanation. You can't just put a number line. The number line essentially is what helps us, but it gets you no points on the AP exam. You have to write the explanation. So let's say you didn't write the explanation. You want to just, you're not confident in that. You can also justify it by just checking all 3 points. So to get these points, it's the same as what we did in step A. F of (-1) equals f of 0 plus the integral from 0 to (-1) of f prime of x dx. We actually already did 4. So for our answer for 4, we got 8 minus pi. So this f of (-1) is going to become 6 plus, now the integral from 0 to (-1) is going to be this triangle here. But because we're starting at 0 and going backwards to (-1, even though it's above the axis, because we're going backwards, it's going to be a negative value. So that area is 1/2 times 1 times 2. So it's going to be 1, but it's going to be negative because we were going right to left. So 6 plus (-1, so we get 5. So our value at (-1 is positive 5. Okay, by the way, 8 minus pi, think of it as like 8 minus 3.1. So it's around 4.9. Okay, we don't know exact value, but it's around 4.9. All right, now 2. Okay, we're going to do 2. So f of 2 equals, again, f of 0 was 6 plus the integral from 0 to 2 of f prime of x dx. So we're going to have 6 plus the integral from 0 to 2 is just this part, right? That's where we had done that square. And if you remember when we did the square, we got this area was the 4 minus pi part, right? That was this part from part A. So 6 plus 4 minus pi. So we're going to get 10 minus pi. Well, 10 minus pi is obviously bigger than 8 minus pi, but is it bigger than 5? Well, think pi is about 3, so 10 minus 3 is 7, so yes. So absolute max is 10 minus pi at x equals 2. All right, D says find an expression for g prime of x and g double prime of x. So g prime of x, we're going to take the derivative. When we take the derivative of this, the derivative of 3 just goes to 0. And the derivative of this, we plug it in. So it's 2f prime of 2x, and we're still going to have the plus 1. The reason we still have the plus 1 is we're plugging in x to 1, and when you plug in x to 1, it's just 1. The 1 doesn't go away because it's inside the integral, right? We're basically keeping this the same. We're not taking its derivative, we're keeping it the same. I saw when some of you guys turned this in, you removed that 1. We're not taking the derivative of the 1. We're taking the derivative of the 3 because it's outside the integral. So essentially, if we wrote, right, we had 3 minus integral from (-1 to x of 2f prime of 2t plus 1 dt. What you would kind of write is that we're taking the derivative of 3 and we're taking the derivative of the integral. The derivative of 3 is 0. The derivative of the integral, everything inside remains the exact same as it was. So you keep it the same, except that the t's you write as x's. Now for g double prime, we will be getting rid of the 1, because now for g double prime of x, now we take the derivative of each part. So the derivative of 2f prime of 2x will become 2f double prime of 2x times 2. And then the 1 goes away. If you wrote that as 4f double prime of x, that's okay also. Okay. So now, does the graph of g have a local min, max, or neither at x equals 2? Well, if we're looking for that, all we're really looking for is then just kind of make a number line, put in 2, put in G prime, right? So let's plug into G prime something smaller than 2, like say 1. And if we plug in 1, right, G prime of 1 would be 2 F prime of 2 times 1 is 2 plus 1. Okay, F prime of 2 on our graph, right? Let's go ahead and there's a lot of this stuff to make it a little bit easier to read. Okay. F prime of 2 on our graph is this y value because it's the F prime graph, so it's 0. So 2 times 0 is 0. 0 plus 1 is 1, but all we cared about, because we're doing a number line, is that it's positive. Okay, and then after 2, let's say 3, right? Do we have a nice value for 3? Yeah, it's -1. So the value at 3 is, oh wait, we got to double it to 6, right? We're going to double whatever we're going to use. That's okay though. Let's see. Okay, this is a little bit weird. So what I'm going to actually do, I'm not going to use 3 because what happens and what we need to be careful about is yeah, we want to be careful on this one because we do see this second thing here. We want to use something as close to 2 as we can. Well, let's see what would happen if we use 3. So if we say G of 3, that would be 2 F prime of 2 times 3, right? Because we have this. Oh, wait, that's why. Okay, my bad. It's because it's, oh, yeah, okay. I don't know what the heck I'm doing. I'm using the wrong function. We were doing this one, okay? So 2 F prime of 2 times 3 is 6 plus 1. Okay, 2 times F prime of 6. So F prime of 6 gives a negative value. I don't know what it is, but it's like negative 0.25. So that gives around like negative 0.50 plus 1, and that's a positive value. But what I did notice, and that's why I wanted to point out, is we totally passed through this point here. And this is something they're not going to do this to you on the AP exam. But essentially, we don't know because we got all the way to 6 because we're doubling this. We know that there might be something also like a critical point at 4. So we want to be careful about that because there might be something way out there. So what we can do is if we plugged in like say 2.5, right? 2.5 doubling it is 4. Sorry, it's 5. If we plugged in say 2.5, when we do this guy at 5, F prime of 5, right? If we estimate this, I don't know what it is, but it looks something like negative 0.75. And 2 times negative 0.75 would be negative 1.50. And negative 1.50 plus 1 is a negative. So it's weird to think about, but this actually increases and then decreases, and then it's going to increase again later. So directly after x equals 2, it's actually increasing or like decreasing, and that's weird. Now, a better way to do this than actually plugging in our values would be to just think, okay, well, what's happening to our graph is for G prime is equal to F prime of 2x times 2 plus 1. So when we're thinking about G prime at 2, right, it's 2 times F prime of 2x would be F prime of 4 plus 1. And so because, oh shoot, sorry about that. Because when we plugged in 2, we're getting this F prime of 4. That's this guy here. Okay, we can tell that we're going to have some kind of a critical point there. So it's a little bit weird to think about, but on that graph, we're going to have a critical point. So anyways, that was E. It went from increasing to decreasing, so it's a local max because F prime of 2 changed from positive to negative. Or F prime changed from positive to negative at x equals 2 is better. Does this graph have an inflection point at x equals 2? Now we want to do the G double prime of x. So we're going to make a number line for G double prime. And again, it's best in this case to try to plug in something as close to possible, like G double prime of 1.9. So 2 times F double prime of, let's say, 3.8 times 2, so that gave us 4. So I'm going to just put this as 4. Right, because we're using this guy. So 4 F double prime of 3.8. So 3.8 is about here. That's a negative value, and it's like negative, I don't know, 1.75. But regardless, 4 times a negative is going to remain negative. Then G double prime of, let's say, like 2.1 is a little bit better than plugging in a bigger value in this case. So 4 times F double prime of 4.2. And again, 4.2 is a negative. So no, because G double prime of x does not change signs. And if you want to say it's negative before and after, that's okay, at x equals 2. Okay, this was definitely a weird question. I think we went over it pretty thoroughly. I know part E was a little bit funky, but that should help out. All right, this one I thought was a lot more straightforward. I definitely thought that this one was a little bit easier than the other one. So on this one, 140. So A was let m of x equal f of x cubed. And find m prime of 2. So A, we are going to do m prime of x first. We get f prime of x cubed times 3x squared because we have to do the chain rule. So m prime of 2 would be f prime of 2 cubed is 8 times 2 squared is 4. 3 times 4 is 12. And f prime of 8 on here is 4. So 4 times 12. And you can just leave your answer like that. If you want to put 48, great. But you can leave it like that. This guy, we're pretty sure we're going to do L'Hopital's, but you do need to show it's L'Hopital's. If you're stressed for time, even just putting 0 over 0 and writing L'Hopital's, I think you'll get the points. But it's better to actually plug it in and just make sure, just on the off chance that it's not L'Hopital's. So this becomes, when we plug it in, g of f of 5 minus 5 over 25 minus 25. Then f of 5 was 1. G of 1 is 5. So we get 5 minus 5 over 0. So we get 0 over 0. So that means we can do L'Hopital's. So it's best to just kind of show that. So then we're going to rewrite the word limit as x approaches 5. On top, when we take the derivative of the top, we're going to do chain rule, right? This is like having g of some box. So it's g prime of our box, which was f of x, times f prime of x, and then minus the derivative of x is 1, all over 2x, right? The derivative of 25 goes to 0. So now when we plug this guy in, now this becomes g prime of f of 5, right? F of 5 we said was 1, times f prime of 5 minus 1 all over 10. G prime of 1 is negative 4. F prime of 5 is 2. So negative 4 times 2 is negative 8 minus 1 is negative 9 over 10. All right, any questions on A or B? I think they were pretty easy, but if you have a question, let me know. If not, just look at your work, see if you made a mistake. And then C, C is just applying that FTC. But because we have something other than x, oops, I'm gonna go d dx. Because we have something other than x, what happens on C is we got to do chain rule on this guy. So this is why I do recommend writing this d dx and just kind of putting the arrows to both, because there will be a chain rule. So first we're going to do h prime of x. The derivative of 3x goes to 3. Plus now this is going to become 2x g of x and the x squared. And the reason for that is, right, we plug it in, like this stays the same, but we plug in x squared. But because it was x squared, we also need to take its derivative with the chain rule. So that was that one caveat about FTC. So this becomes 3, f prime of h prime of 2 is what we're looking at. So 3 plus 4, g of 2 squared is 4. And looking at our table, g of 4 is 10. So 3 plus 40, so h prime of 2 becomes 43. Okay, next we're going to do it with h double prime. So h double prime of x. We're going to want to take the derivative of this. So the 3 goes away. This is going to be a product rule because I have two x's. If I have two different x's and they're multiplying, we're getting product rule. So derivative of the first is 2. Keep g of x squared the same. Then plus, now I'm going to keep my 2x the same. And times the derivative of g of x squared will become g prime, right? This is like a box. So g prime of the box of x squared times 2x. If you want to simplify it, you can. You would have like the 2x and the 2x would multiply to become 4x squared. I'm not going to. I'm just going to leave it like that and plug in 2. So this becomes 2g of 4 plus 2 times 2 is 4. G prime of 4 times another 4. Okay, we said g of 4 before was 10, so this becomes 20. G prime of 4 is 4, so this is 4 times 4 times 4. That's 4 cubed, which is 64. So we get 84 here for h double prime of 2. So how are we feeling about those guys there? Were they, what do we think? Was it easy, hard? Which parts were the hardest for us? Medium? Yeah, I think you're talking about the one from the video or the one from the I didn't go over this one because it was in that video. This one was harder or this second guy was harder? The second one, yeah. Okay. Um, um, okay, so tonight for homework, and I wanted to go over that kind of in depth just because I thought they were really good questions. Um, so tonight for homework, we are going to have the 2017 exam. Um, and kind of just looking at it, um, number one is we have a table with a tank, and it gives these values. It does have water going pumped into a tank. Um, and so then it says using this model, find the rate at which the volume of the water is changing with respect to time. Um, and so actually this one's interesting because number one is actually a table question with a related rate at the end, which makes it a little bit unique. Number two is this weird banana question. There were a lot of memes about this question, but essentially it's just a rate in, rate out question. Like everyone was like, "Oh, the banana question was so hard. The banana question was so hard." It's really actually an easy rate in, rate out question as long as you recognize that. People were just getting triggered because there was a formula for bananas in a grocery store. Number three is another one of these graphs of f prime. So these f prime graphs, sometimes you'll see these as like called like stem graphs, but I just call them f prime graphs. And then number four was another one that triggered a lot of students because we had this, again, this formula for a baked potato. And they're like, what the F, if I'm going to do a baked potato, I'm just going to, put a timer on, not have some weird calculus formula. But again, the AP test is just, they're trying to come up with context that you haven't ever seen before. So ignore whatever it is. It doesn't matter. Like, don't waste your time thinking about that. Just look at it. We have a dH/dt. And whenever we see, like, think dy dx, right, that's that differential equation. So A is a tangent line. We've done that with dy dx. B is just take its derivative. We've done that with dy dx. And C gives a new differential equation. And then it says find an expression for g of t. So that's going backwards, taking the integral. That's that when we separate it, like put dy on one side, dx on one side, and take the integral. So number four was a differential equation, but just kind of with other variables than y and x. It doesn't make it any harder. It's just, you just use t instead of y, or t instead of x, and g instead of y. Number five has two particles. One is a particle moving to the left. When are they traveling in the same direction? So if they're traveling in the same direction, what do you guys think that means? Same direction. What's the same? Is position the same? Is velocity the same? Or is acceleration the same? What do you guys think? Either hop on the chat or put that in the comments. I mean, or, yeah. Yeah. So same direction would mean that, yeah, they need to have the same velocity. And then find the acceleration and find when the particle changes direction for the first time. And number 6 was let this function be defined by cosine of 2x plus e to the sine x. So this one is a little bit interesting because it kind of falls in that other category. If we look at it, this is like taking a derivative. That is chain rule. That's product rule. Slope of the tangent line is literally just asking for f prime of pi. You don't need to do the full x1, y1, m because it just wants the slope. And then C, is there a number C such that g prime of C, that's MVT, IVT, right? When we see that wording, we think MVT, IVT. So that's kind of just going through each of these. Okay. I wanted to kind of look at this and like kind of preface it just by kind of showing us that. So we said 5 was our particle motion question, like velocity acceleration stuff. And 6 kind of falls into that other category. So what we're going to do is we are going to do the odds tonight for homework. So 1, 3, and 5 tonight for homework. And the evens, I'm going to give you guys over the weekend as your homework. Now, I do want to just talk about tomorrow. Okay. And I'm going to put this in the Google Classroom, and we'll see how many of us we can get. If you guys saw my post, I kind of had a post a little bit late last night, just about grading. So essentially, and I'm still open, I'll talk to some of the other AP teachers and see exactly what they're doing. But essentially, originally, the way I had the class set up for second semester, I've done this pretty much every year, is because second semester is so important about the final, is that your homework was worth 10% of your grade, which is not a lot. Your tests were worth 25% of your grade. Your quizzes were worth 5%. And your final was worth the absolute most, was worth 60%. So you still couldn't pass. Like if you got 100% on the final, you still can't pass without that stuff. So it's still important. But your final really does make or break you. And that's how I had it in the past. I'm open to changing that, to kind of lowering that amount and adding it into some of those other categories. But for right now, since we haven't even taken the final, we don't have to worry about it. Essentially for right now, it was just that your tests were basically worth 2.5 times as much as the homework, and they were worth 5 times as much as your quizzes. Well, because with distance learning, we haven't really been able to take a whole lot of tests yet. I didn't think that was fair to your grade. It was basically just chapter 9 test and chapter 10 test, which we took back in February and early March. So what I did is I just switched these, right? The average grade right now is like a C. I switched these to make homework worth the 25% and tests worth the 5 or 10%, and kept quizzes the same. And so our average grade went up to a really high B. So, and a lot of you guys had A's and B's, so that's cool. I'll think once we get the final, I'll see about adjusting it and how that works. But I do want to give you guys some opportunities for that test score, because some of you guys who don't have A's, you've turned in all of your homework, but you don't have an A because you just really didn't do that well on the first couple tests. So what we're going to do is maybe once, maybe even twice a week, since we're getting really close to the exam, but definitely once a week, we're going to do kind of like a practice run of our test. So what I'm going to do is that on Friday, okay, I want you guys to join the Zoom, okay? And this is going to be a little bit weird, but what I want, just to kind of encourage you guys really not to cheat, and it is a little bit on the honor system, but it kind of is what it is that basically in the Zoom, I want you to either turn on your mic or turn on your camera. Okay, you can, if you got like, basically what I would recommend is put like, say, put your volume to 0 on your computer. So if you have your computer on, put your volume to 0. That way you're not hearing other people. So like, say, like I remember one time Cassie was saying she didn't want to turn on her mic because like there was a baby crying. Don't worry about that, because everyone else is going to put their volume down to 0. I'm going to be the only one who's can hear, and I don't care what's going on in the background. I'm just making sure that you're not on the phone with a classmate. Or if you don't want to turn on the mic, just turn on your camera just so I can see that you're not talking to anyone. Really, if you cheat, it's more on you. This isn't to try to like really cheat. It's really just to practice the test. And then what I'm going to do is I'm going to just, in the chat, we can attach those files. So what I'm going to do is I'm going to attach number 1, and I'm going to start a 25-minute timer. When that timer goes off, I'll put the timer on my screen so that you guys can be looking at the Zoom for the timer. When the timer goes off, you'll have 5-minute time to upload it to Google Classroom. And when that 5-minute goes up, you'll get number 2. And then you'll have 15 minutes. And when that timer goes up, you get 5 minutes to upload. And so that's kind of the format of the exam. Okay, they did post some videos as well. I'll be posting them later. They did post some videos about the format of the test and something called like your exam key that's going to get emailed to you. They're going to do some practice things on May 4th. But essentially, I just want to get like our own practice and, give you some possibility to really, the goal here is to increase your grade. Okay. If you don't do well on this test, you'll have a retake. If you absolutely can't make it, right, because this is going to be at 8:30 a.m. And for this one, really, really try not to be late. Okay. What I will do is, just to make sure there's no issues with the waiting room and things like that, I'm going to log in that morning at 8:15. So tomorrow morning, I'll log in at 8:15. And then at 8:30, I'm going to start the timer. So at 8:30, I'm going to, on the dot, upload the file and start the timer, so that we can really keep this to an hour and kind of go from there. Now, if you can't make it, like I said, there'll be, just talk to me and we'll schedule some kind of a makeup thing. And don't stress about it. As far as what you can use, okay, it's really pretty much open everything right now. But just with the understanding that, yes, it is open everything, but you have 25 minutes and you have 15 minutes. So if you're counting on, I'm going to look through my entire notebook and I'm going to have every single test I've ever taken out, that's not the right idea. What I would kind of encourage you guys to do is to try to create some kind of like a 1-page cheat sheet with your own kind of top ideas. And what I will do is, if you actually submit that to the Google Classroom, I will give you guys some extra credit. And the extra credit, actually, when I was looking at, this doesn't seem like a lot, but it's actually huge, is when I was given the extra credit last night, the way that the assignments work this semester, right, everything's out of 5. It's like that 5-point scale, right? And so what I was doing is I was just putting it in as a homework and giving you a 10 out of 5. And what that was doing to everyone's grade was if you were at like a 3.1 grade, it was taking you to a 3.2, sometimes even a 3.3. I know that seems like, oh, it's only 0.1, right? When you're thinking about out of 100, 0.1 is really, really small. When you're thinking about out of 5, 0.1 is huge. 0.1 out of 5, you can almost even think about like, right, that's 20 times as much. So relative to 100, 0.1 is nothing. Relative to 5, 0.1 is freaking absolutely huge. So that extra credit actually helps out a lot. So if you want to submit a 1-page cheat sheet to the Google Classroom, that'll be extra credit. But you know, ideally, I won't put a date on that. Like, you know, maybe if you end up doing it later, that's okay. But ideally, you upload that tonight and you do that assignment tonight, because this test is tomorrow. Okay. Now, as far as, like I said, these odds are tonight's homework, and then the evens are going to be the weekend's homework. If you're a little bit behind and you would rather just catch up and work on your cheat sheet tonight and do everything over the weekend, that's cool. I don't care. That's totally fine with me. Okay. On Monday, I'll go over any questions that we had on this, but what I really want is I want to make sure that all 6 of these are absolutely turned in by Sunday. But just so you don't have too much homework, what we can do is 3 are technically tonight, 3 are technically over the weekend. Okay. Set 2 alarms, Alvia. So the last thing before we go is, just because I'm not going to do any of these questions, very quickly, A, use a left Riemann sum, should be easy. B, overestimate or underestimate. Remember, for Riemann sums, it's dependent on, are they increasing, right? Then the left is under and the right is over. Or are they decreasing, then the left is over and the right is under. The area is given by this, the area is given by this equation now, and it wants to know, based on this model, what is the volume. Okay, this is just knowing that volume is always the integral of the area. So in this case, it's just literally going to be that volume is going to be the integral of f of h, and you're going to use your endpoints that you have. Okay, so that's all C is. Then D, water is now pumped into the tank, and when the water is at a height of 5, they want to know what is the rate increasing or decreasing. My hint on this one is that if we know that volume is equal to the integral, essentially from 0 to some time of f of h dh, well, then if we want to know what is the rate the volume is changing, they want to know dh dt. Okay, so in order to find the derivative, we're going to be doing, sorry, dv dt. We're going to be doing dv dt. So we're going to do the derivative with respect to time, the derivative with respect to time. Well, what's going to happen is that this is going to plug in. So dv dt is going to be equal to dv. This is a little bit weird, but it's going to be dv dh times dh dt. Okay, and sorry, this is because this is an h here. This should have been an h, and this should have been a t dt. or really x dx, whatever you want to write it as. So it's going to be dv dh times dh dt. That one's really weird. Honestly, on D, you might just look at the answer and try to figure it out from there because it's such a weird question. A lot of my kids on this exam, several of them did get 5s. They all said that they got that part D wrong. All right. B, how many pans of bananas are removed should be obvious. F prime of 7 should be obvious. Is the number of bananas increasing or decreasing? You're just going to look at the total rate, and is that positive or negative? So right, the total rate is just the rate in minus the rate out. And D, how many pounds? That should be like our general formula. This question was actually very easy. Number 3, I'm not going to go over finding the values of F, right? Those are just those integrals, right? You're doing the area under the curve. You do need to make sure that we think about F of negative 2 equals 7. So the issue with number 3 is that they gave us the graph of F prime, but we don't have any formula, right? But what would our generic formula be? It would be that any F of, say, like negative 6 would equal, right? What's the other point we know about? Is negative 2. So F of negative 2 plus the integral between negative 2 and negative 6 of F of t dt. So if we wanted a general rule, what you can do is, well, the F of negative 2 is our given. So you could get rid of negative 6 and just put like an x if you wanted like a general rule, and then you can have that as your formula. So F of x equals 7 plus the integral from negative 2 to x of F of t dt. That's like the general formula. Okay. When is F increasing? You have a graph of F prime, right? It should be really easy. It's increasing when it's positive. Find the absolute minimum, right? We've done that. Look for the zeros, make a table. If you want to justify by taking some of those things out, you can. For each F double prime of negative 5 and F double prime of 3, find the value or explain why it doesn't exist. Right, the values of F double prime would be the slope of F prime graph. So if we have a kink or a corner, it doesn't exist. If otherwise, if it's like linear, we can do that. Elvia, you said integral. You had a question about the integral. What was that from from the first question, like the volume thing? Okay. Question 3, I think I just did. Yeah. Question 4 is this baked potato question. Tangent line, I'm not going to go over. I think we should be okay with tangent lines, right? Tangent line, and then use it to plug in 3. The one thing is just normally we're doing x1, y1, and m. Just for your variables, realize that in this case, x1 is similar to t, y1 is similar to h, right? So h of 0 is 91. That's your x1 and your y1. And m is dh dt, which was the equation. So the variables just kind of match up with that. Okay, B, use dh squared dt squared, like the second derivative. So you need to take the second derivative. To me, it was easier to first distribute. So write dh dt equals negative 1/4 h plus 27 over 4, and then take the derivative of that is very easy, right? It's just negative 1, right? Negative 1/4, but you need to do times dh dt. So you do need to make sure that you do implicit here, right? Because we're taking the derivative with respect to time, and h is not time. So when we take d dt here, right, h is not t. So the second derivative becomes the derivative of negative 1/4, h would be negative 1/4, but then times dh dt. We do need to do that implicit, right? Anytime you're taking the derivative, like look at the bottom, anytime that bottom is not the same as the variable, you do implicit. So if we were doing like v equals t squared plus 4, Well, we're doing the derivative with respect to time. Oh, this is time, so we're cool. The derivative velocity is a, and we just get 2t, right? But a really is dv dt, so we kind of did implicit on that, like 1 dv dt. But here, t squared is the same variable, so it's just 2t. Technically, it's 2t dt dt. Technically, you're always doing that implicit, but that's just 1. So anyways, to get this, my computer might just fritz out for a second. Okay. To get this right, this will become -1/4 times another -1/4 h minus 27, because that's what dh dt is. So that's my hint to you guys on that one. Okay, and then C, it says find an expression for g of t. That's right, we have the derivative. How do we get from the derivative back to g? That's where we move our y's to one side and our x's to the other side. Well, the issue is this is g instead of y, but treat it just like it was a y and just like it was an x. So we want to put dg divided by g minus 27 to the 2/3 equals -1 dt, right? I divided that, I moved times dt, and I moved the g to the other side. Now we can just take the integral of both sides, and this is like having the integral of g minus 27 to the -2/3 power dg equals -1 dt. The right side integral is very easy. The left side integral is actually pretty easy also, right? The integral of y to the -2/3 would just be add on 1, would be y to the positive 1/3 divided by 1/3, and when you divide by 1/3, it's like multiplying by 3. This is going to be the same thing. Technically, it's u sub, because u is g minus 27, but du is 1. So remember, we said when the du is 1, it's just the exact same. So it's just that exact same thing, but with, instead of y, g minus 27. So that's a hint for you there. 5, 2 particles move along the axis. A is easy. 1 is the particle moving to the left, right? What would moving left indicate? What would moving left indicate? What needs to be positive or what needs to be negative? What do you guys think? Okay, position doesn't have to be negative to be moving left. Something else has to be negative. So moving is not position. Yeah, so moving left means that the velocity needs to be negative. So in order to do that, essentially step 1 would be to set the velocity to 0, right? We have particle P. They gave us an equation for x of particle P. So how would we get from position to velocity? We would have to take the derivative. So in part A, step 1 is going to be to basically take the derivative of that to get the velocity and set that equal to 0. And then you can kind of do a number line on that and figure out where is it negative. Okay. Part B wants to know where do they have the same velocity. Well, we're going to actually want to, what I did on this is I just made a number line for both of them. So I made a number line for the velocity of P, and right underneath it, I did a number line for the velocity of Q, right? This one for P, you had to take its derivative, right? Because it started with X, but for Q, it already is the velocity. So you're just plugging it in. But you might want to factor it to get the, right, like set it equal to 0 to get the critical points. And then factor it to make it easier to plug in. But essentially, I just made a number line for both of them and then just looked at where the positives and the negatives kind of overlapped to see where does it have the same sign, right? Because we were saying that we want to have the same velocity. So the velocity charts need to have the same sign. Okay. C, find the acceleration of Q, and is the speed increasing or decreasing? So acceleration would just be the derivative of velocity. Speed increasing or decreasing, remember, was when VQ and AQ of, right, 2, because that's what they're asking at time 2, do they have the same sign or do they have opposite signs? And D, find the position. The first time the position of Q changes directions. Okay. So find the position of particle Q the first time it changes direction. So what we're going to need to do first is figure out what is the first time it changes direction, and then find the position of that. So in D, the first thing would be, when does it first change direction? Well, you should actually be able to do that from this number line that you had in D. Looking at that number line, the first time it changes from like positive to negative or negative to positive, whatever value this was, that's going to be the first time it changes direction. Now we want to do x of that number equals, they gave us an x of 0 plus the integral from 0 to that number of v of t dt, right? That's how we would go back and find the position. So those are your hints on number 5. And number 6, I'm not really going to give you any hints because it's just, I think it's pretty straightforward. I think I already gave them to you, right? A, we're not asking to find the full tangent line, just the slope. So essentially it's just asking for f prime of 4. B is chain rule. C is product rule, but with a small chain, right? Because when you do the derivative, the g of negative 2x, you're gonna have to multiply by negative 2 and times h of x. And C, when we see this, like, right, we said we're thinking MVT or IVT to figure out which one. Look at G prime of C. And then if you're going to compare it to the G prime part, you'd be doing IVT. If you're going to compare it to the G part, you're going to do MVT. So look through, you know, basically I want us to try to do this as much on our own, but I gave you guys a lot of hints here. I will post today's video. I know last time I didn't, and no one reminded me until really late, but I just set an alarm on my phone. The issue is it takes about like 2 hours for these things to process. It's just crazy long. And then once they process, then I can upload them to YouTube. So I set a timer for 2 hours from now to go back and upload this. So I will post this video so that you guys can kind of skip to the end and look at these notes while you work on it for homework. But big thing is just, I would try to make that cheat sheet, get the extra credit and have it for the test tomorrow. If it ends up running a little bit longer than a page, no worries. It's just that you want something that basically something that helps you, 1 or 2 pages you can look at, has like the big kind of key things there. For the test, okay, I mean, there are going to be other things, so it's not like there might be something like D here, like an MVT, IVT, but my hint is definitely know how to do something like question 3, right? And definitely know how to do something like question 1. Now, there might be additional stuff in here, right? Like question 6 with some of these, like throwing in product rule, you know, chain rule with the table. There might be something about continuity in a piecewise, but the big thing is that, yeah, one of the questions will have a setup that's similar to this graphical stem, and one of the questions will have something with a table. Okay. All right. With that, I'm done. Good luck tomorrow. If you have any questions, let me know, and I'll see you guys later.